Another day, another recording. Welcome back. Shout out GitHub followers. Jose, that's my go right there. Gotta make the Pokemon sound of the day. That's Nido King, as you can see. Let's take a listen. Sounds like just like a roar. I think I'm gonna start off with a good amount of Leetcode today, like 2 or 3 problems maybe. Yeah, but we're gonna start out with the Leetcode problem of the day, which is a fucking man. Why is it gotta be a hard problem, dude? Wait, is this? I feel like this shouldn't be that hard. You remove 3. Hold on. You remove 3. You remove 2. 4. Wait, what? You remove, but you keep it? You remove, if you remove the 4, hold on. I don't get it. Why don't you just make the parent equal, like, okay, so you get to 4, you see the parent is 1, and then you just do, you make it null, and then you're done. Why is that not the solution to the problem? Okay, let's do this one. We got 3, 2, 4 isn't even in the tree anymore, though. The path becomes 5, 8, 1. 5, 8, 2, 6. Wait, what? Wait, maybe I'm not totally understanding this problem. Removing the subtree rooted with value 3, the height of the tree becomes 3. Is it? Oh, you just have to get the height. Oh, and then you add it, you like add it back? Why is it 2? 1, 2. That makes sense. So the tree returns to its initial. I feel like, am I tripping or is this problem not that hard? Like, okay, now I'm just trying to think if I want to use BFS or DFS, but basically it's going to go like this. I have the root. If I detect this connection, I'm just not going to pursue it. It's like if 1 is equal to 4, or if, no dot left, no dot right is equal to 4, just don't do anything. Dude, what? Okay, hold on. This can't be hard, bro. I'm missing something. Is the root always non-null or whatever the? Okay. Yeah. For query, how do you spell query? In queries, we need a DFS function. I don't even need like. Is that gonna? Isn't it just like if? Oh, and a depth. Can't forget. If cur and cur dot left doesn't equal query. Cur. Hold on. Hold on. The problem with problems like this is that I swear they just require so much like boilerplate, and I just like always think about how I want to reduce the boilerplate, because it's like I have to check if not the current node, and then I have to check if not, and then I want to check the lead or this children. So like this is the current one, right? This one, and I have to check the children. But to check the children, I also need to check if they exist, and then I can check the children, like the value. So I end up checking like if this exists, if this exists, if this exists, if this value, if this value. I'm doing 5 computations, bro. I ain't trying to do all that. Okay, if not cur. I'm not gonna lie, guys. I just took 2 of these right here. I took 400 mgs of caffeine, androgynous or whatever. So, anhydrous. So I'm low-key about to be bouncing off the walls, but no coffee machine. If any of y'all want to buy me a coffee machine, hit me up. Okay, if not cur, return. Okay, if cur dot left and cur dot left dot val doesn't equal query, is it gonna like time me out? Like, why is this hard? Okay, whatever. I gotta stop. I'm like so scared of hard problems. Okay, if cur dot left and cur dot left dot val doesn't equal query, DFS cur dot left depth plus 1 query, and I'm just gonna do the same thing right here. If cur dot right and cur dot right dot val doesn't equal query, DFS cur dot right depth plus 1 query. And then I'm gonna have a thing for query in queries. I'm gonna have a max depth equals 0. It's gonna be non-local max depth, and then it's gonna be max depth is equal to max of max underscore depth, max depth, and then it's gonna be DFS root. Is it 0? Yeah. And query. And I realized that I have already made this down here. So what is wrong with this code here? That's the problem. It's, do I TLE? Is that the problem? Unreal, bro. That's the problem. God damn. They wouldn't let me off the hook that easy, bro. Time limit exceeded, bro. But of course. Okay, that's fine. How do I not time limit exceed? What was the thing? Do I need to do it in one pass of the tree? Is it a binary? No, it's not. I was going to ask if it's a BST. Ah, man. Okay. But it says, look, it says right here. You are also given. You have to perform m independent queries on the tree. Where in the ith query, you do the following: remove the subtree rooted. Is it like lying? Is this line lying to me? You have to perform m independent queries. It's lying to me then. Or there has to just be a way faster way to do it. No, I'm just rechecking the nodes. Is this like a DP problem? Is this a DP and a tree problem? Is that what's going on? Where I have to like cache the depth of each thing? But like somehow I have to. Yeah, this is trickster. This is a little bit of a trickster problem. This has got to be a DP problem. This has got to be a tree DP. I kind of want to check the topics, but I think that's cheating. But also, I just have no idea how to solve it. Man, how the hell do you do this, bro? How do I cache it? The issue I'm having is like, okay, let's say I want to throw away this 2, right? Like, how do I know anything about these nodes? Like, how do I know to, like, if I see this 2, I know that these are connected to this 2. Like, how do I want to manage that? Because, like, let's say I throw away this 8. I need to know that all of these nodes are connected to this 8. And I just have no idea how to do that. Man, it's got to be some DP. I'm trying to, like, think of the array that would help me solve this problem. Like if I did something like level order situation, like 5, and then 5 is connected to 8 and 9, which is connected to, like, and this 8 is connected to, like, 2 and 1. You know what I mean? Like, and then this 2 is connected to 4 and 6. Like, okay, I think that what needs to happen is, like, I get this query, I need to be able to get the depth in O of 1. I can't do O of n, obviously. Like, I need to set up something with the tree, and then these queries need to be O of 1. And that's why they're queries. How the fuck do I do that? O of 1. O of 1, just 1. Not 2. Not even 3. I'm going schizophrenic. And how do I mark? How do I mark? I'm thinking about using, like, some sort of hash map or something, but the problem, this doesn't even work, because this is just a tree structure with an array. Like, I mean, obviously this is, like, not valid, but I mean, like, the thought process is the same thing as the tree. Like, I need to not keep going, like, okay, query 3. All right, let me go start from here. Oh, here, you know? Okay, what if I have the depth of every node? Like, okay, this is 1, 2, 3. So this is 3. This is 2. This is 2. Wait, 1, 2, 3. 1, 2. This is 1. Oh, wait, no, is it reversed? So this is 0. This is 1. This is 2. Yeah, maybe. But it's how deep it can go. Like, I don't want to check the bottom ones. So this is 1, 2. This is 3. This is 2. This is 1. These are both 0. Something like that. Where then, like, I can check, like, okay, at 5, but then how would I know if it's on the left or the right? Because it could be 9 and it's still the max number. How the hell do you do this? How to make query O of 1. It's the depth. It's not even like something like too challenging. Okay, it's not DP. I mean, I don't know why it would be DP. I'm just talking about a caching. It's not some DP magic. And I have the knowledge to be able to solve this problem. I just can't figure out the trick. Like, how can I get the depth and just know at all these queries? Same problem. My brain just keeps defaulting to what solution I already have like printed out. And it's not log n either. Like, that's the thing. Like, I can't get rid of half the tree. Like, if the query is 3 or like 2, I think 2 is a better example. Well, I can go either way, technically, I guess. But like, I don't like this 1 could stretch down to infinity. Like, I can't like eliminate this left side because I know this 2 is here. But I think that was right. Like, if you know this 2 is a depth of I feel like I kind of just had it. If you know this 2 is a depth of 1, okay, I have an idea. So I assign each node should have a set pertaining to the parent nodes. So this is going to have 2, 8, 5. This is going to have 2, 8, 5, right? So if we know if 2 is in this, what does that tell me? Does that even tell me anything? I need to know how far above it is, because it could be here. And then what? And then I'm cooked. But if it is here, couldn't I just... Hold on. Okay, so if this is 1, 2, 3, 1, 2, 3, 2. So this is 3, 3, 2, 2 depth wise. And then I check the query of 2. I see that this one has 2. So I just throw it away. I throw it away. I throw it away. I take the max of the depths. I take the max of the root nodes or the leaf nodes that don't have. That's gotta work, right? Right, guys? Okay. Okay, let's set that up. So I need an array. Okay, I need an array of sets of, oh no, dicks of array of dicks of leaf nodes and their depth. And it needs to, is it a tuple? Like if this is a leaf nodes plus parents, so like it's like it would be, for example, an entry would be like, so for 4, right? 4, it's the first one. We're just gonna make the root the first one, but it's a set. It's unordered. Shoot. No. It's not how that works, is it? No, they are. You can order them. So before 2, 8, 1. So like I would, like for 2, I would check like within this one, like, oh, 4, like is 2 in here? Oh, it is? Okay, move on. Okay, 6, 2, 8, 5. Look at this one. Wait, is this one here? Wait, is 2 in here? Yeah, it is. Okay, move on. And it's just the length of it. -1. And that's the depth. Wait, I don't have to do any work then. Wait, so this could just be like, wait, is length? Len works in all one time, as the set is an object has a member to store its size. Yes. I mean, when I abuse Python's like bullshit. Okay, this 3 is gonna have 9, 5 in it. Oh wait, this one doesn't have a 2? Okay, this is the max one right now. So it's not gonna be O of 1, it's gonna be O of the leaf nodes, amount of leaf nodes. So we gotta do some pre-processing maybe. Does that work for all of them? Let's say 8. I mean, yeah, 2, obviously. 4, 3. Bro, this has got to work. I'm not even trolling. Dude, if this works, I'm Dr. Deadly Genius levels of fucking coding. I'm not even joking. Okay. Okay. Now I gotta... Now I actually got to think about how to code this. I don't actually know how to code this, guys. How to add to the start of a tuple in Python. What? Oh, not a tuple, of a start of a set. Yeah, I was kind of scared of that. I don't really need the leaf node, right? What if I have a set array of dicks where it's parents, depth, and this is a tuple or a set. It's a set. So then it would just be like 281, and then the depth is, it's just the length of this. I don't need it. It's the same problem. I don't need it. How to do it? Add, pop, add, pop. I don't, is that, okay, def, dfs, cur. If not cur, return. Okay, we need like a set. It needs to be like, that's the same problem, dude. I like low-key really need it to be ordered. It doesn't need to be ordered. You just know, like. Okay. Okay, if not cur dot left and start here, append, add. When do I pop though? Like I need like a visit and then like visit dot add cur dot val. Maybe right here. Visit. And then like visit dot remove cur dot val or something. I need to backtrack it here. Dude, I really feel like this is the right way to do it. And like I know this problem is gonna take me forever, but I think if I get this, I actually solve my first hard problem, like legit. That's the thing. I don't think this is right, but I'm gonna run it and see what happens. Oops. Set. Okay. Well, I need a copy of it. Deep copy. Oh, I really gotta go to the bathroom, guys. All right. I'll be back. Okay, I'm back. Yeah, so we're just gonna do this right here. That didn't work. Man, where do I put this? I know this is how you do it. I know this is how you do it, bro. I'm not even joking. Wait, I did it. I have it. It's right here. Wait, I did it. I figured it out. Okay. All right, 4. Dude, it'd be so sick if I got this one. Okay, 4 query. And dude, I'm not gonna lie, that 400 megs is hitting me so hard. I'm actually like... Four. Okay, res. Okay, 4 leaf and R. Oh my god, it's actually hitting me insanely hard right now. I'm not gonna lie. Okay. Okay, if your 400 was too much. I'm actually having a heart attack right now, guys. I'm not even joking. No way. No way. No way. Oh. Wait, what's wrong with this one? Yeah, that would make sense why that's wrong. But I feel like this would only apply to this case. I think I need a dictionary where like 1, 2, 1, 2. Like this is 2, so I just know it's 1. This is 1, and I know it's 0. Because this case would only happen if it was a linked list situation. This would not happen if like if this, that's why yeah. So I think I'm going to, I need a depths where it's going to be node depth. Let's do a depth here. Depth. And then it's going to be depths at spot cur.val is equal to depth. And then if max underscore depth is equal to 0, res.append depths at spot query query -1, and then else all right, give me the submission, bro. Come on, just give it to me. You know you want to. I think I just TLE though. Like the fact that it takes 14 years for it to run is not good. What seems to be the problem now? So I'm getting the wrong one on 3. That should have worked. What? One. Output 1. 1, 2, 3. 2. It should be 2. Wait, but this should be 2 though. Because it's 0. Because there's only, oh, it's 1. I need the max then. Hold on, I'm just gonna keep these if statements. Res.append max of depths of query -1 or max depth, whatever is larger. Why does it take 14 years to submit? I'm so mad. I'm actually so pissed. I'm not even joking. God fucking damn it, bro. But it's right. This is right though. I need another optimization. I need to check if 46 minutes on this hard problem. Not. And I just can't solve it. God damn it, bro. I've solved it, but it's just TLE and I don't. Man, I really thought I had it with this one, dude. I'm not gonna lie. Like, I really thought I had it, but I didn't. Why is this wrong? I don't totally understand why this is wrong though. I mean, no, it's right. Sorry. I just lost my dude. This 400 megs, guys, is absolutely eating me right now. There's like a certain check that's just taking way too long. I mean, also, this could be here. Like, it matters, but... like, it matters. It doesn't matter. Oh. It mattered. Doesn't matter, but it's just like... I can't believe I TLE, dude. I don't know what else to do. Does it really need to be 0-1 checking? This for loop here, for query inquiries must be 0-1. Okay, I don't know how to do it. I give up, guys. I'm sorry. I tried really hard on this one, but I just have no idea. Did Leetcode post a solution by any chance that I can watch?
I've solved a lot
of... shut the... I've solved a lot of problems. Blah, blah, blah. Dude, he hasn't uploaded it yet. All right. Oh my God, let's look at the solutions, bro. How do you do it? Pre-computation. How do you do the pre-computation, bro? Let me know. Depths, heights. How long is this code? What the Okay, hold on. Compute heights and depths of each node. Depth first search. The compute heights function traverses the tree using DFS to compute the depth and height. Okay. Got it. That makes sense. The heights dictionary stores the height of each node, where heights node.val is the maximum depth reachable from that node. Each node's height is calculated at 1 plus max left height, right height, where left height and right height are the heights of the left and right. If a node is none, it returns -1, making leaf nodes have a height of 0. Pre-compute max heights for each level, excluding subtree. What? What is this? Oh, it's right here. Root 0 heights levels. Okay. Oh, my eye. From the root to the current node, the depth of the node from the current root to its furthest leaves. N log n plus q. What the? I don't really understand how you're doing it though. Calculate heights, depths. Okay, I don't like this one. I'm gonna do another one. This one has 4.4K though. Why does it have 4.4K and only 22 upvotes? Is this bucket sort? Dude, what? Dude, I don't get it. Segment tree. Topological sort. Dude, no wonder I didn't get this. What the fuck? DFS plus heap. Okay, maybe these like... Okay, this is kind of... But he's using this weird strat. Like, what is this left and right shit? Okay, I'm actually going to lock in on this one. Since now we have depth from both cases, let's say if at left side node is remove... Nope, this guy can't speak English. X equals max height at particular level. Second largest max. Why is nodes 5? 1, 2, 3, 4. Like, what? Dude, I'm so confused on this problem. What is going on? Dude, I don't want to keep jumping from solution to solution. But, like, what the hell is going on? Dude, I would have never got this. Oh, my God, bro. Okay, let me just go back to this one, bro. No, I don't like this one. Let's go to this one. This guy seems to know what's good. All right? One plus max left height, right height. Where left height and right height are the heights of the left and right subtrees, respectively. Each node, if a node is none, a leaf node, it returns -1, blah, 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 height 0. Okay. It appends its height to the list associated with its depth. I don't know what I'm reading. I don't get it. The algorithm sorts each depth levels list in descending order. Oh, does it now? Sorting allows easy access to the highest to the 2. For each node, the algorithm calculates the maximum height of the tree. If the node's subtree were excluded, storing these values in Okay, I did this. I figured this part out on my own. Yeah, this is exactly what I did. Except he did it better than me. The next tallest subtree. Facts. Finally, for each query and queries, the algorithm retrieves the pre-computed height. Max height without. In constant time. There it is, bro. The constant time. I called it, bro. I called it. All right, I'm cheating. I'm just going to go very slowly. Okay, def compute heights. Node depth. Is this just like, okay. I'm going to call it cur though. He called it, oh, heights is depth. Wait. Depths, heights. Okay. That spot cur.val equals depth. Yeah, that's easy. I get that. Left height. What's that? Left underscore height equals compute. Oh. And then you do it at the end, don't you? Of course you do. Computer. And then you take the max heights. But why does it? Man, this is that recursion that I don't really understand. Max of left underscore height, right underscore height. Return heights, no cur.val. But I don't really get, like, when is this returning a number? Like, how is this getting the max height of the left and right tree? Like, this is the recursion magic. I just don't get where it's happening. I'm asking Claude. Heights cur.val. On none. None. Yeah. That makes sense. Okay, then you go to this 2, right? 2, depth 1. Bro, how are you getting... heights? Oh, because it's getting curved out left and it's returning the 2 here, I think. It's the base case, bro. Ah, man, that's really very difficult to understand. Okay, what's the next one, though? You got this right here. Max height without subtree. Yeah, level max height. Okay, let's see what we got here. Update. Level heights. Node. Okay, calculate the max heights for each depth level. Okay, that's easy, right? If depth not in level underscore. Wait, what? Collect the max heights for each depth level. Yeah, okay, that makes sense what you're doing. This makes sense, bro. Okay, if not node, I'm doing cur again. Okay, if depth not in, well, there's gonna be nothing in there. It's empty right now when I first call it. Level max. Oh, and then you're sorting this array. Okay, level. Okay, guys, I'm not gonna lie. I have like a 50% understanding of what's going on. Maybe less. Like, I feel like I kind of get it, and then I just kind of lose it. Heights. Node.val. And it's cur.val. But, like, why would the... Yeah. Man, okay. Update level underscore heights. Okay, now we gotta sort it. For depth in. So that's key. That's the key. Dot sort. Okay, now we actually do the problem. How do you actually do the problem? For node val in heights, depth equals compute maximum height of tree excluding nodes subtree. Oh, you're doing it before. Oh, okay. Okay, I kind of get it. Okay, so what he's doing is he's doing the whole thing. Like he's computing the max height of this, like without at this spot. Oh. Okay, but like that doesn't really seem that much easier. It's so hard for me to read this code. Like I swear his code is like so. For node val. Depth equals depths at spot. Node val. Max heights equals level underscore max underscore height at spot depth. If len max underscore heights the length of the array is 1. Heights at spot node underscore val equals max underscore heights at spot 0. Dude, what am I reading? What the fuck am I reading? Nope. I don't get it. I don't get it at all. I don't really understand how he's computing the... I don't understand how he's computing the height of each thing without the thing. No, this kind of makes sense to me. You're moving on to the next one. No, I get what this is saying. No, this first line makes sense. No, this makes sense. Because what it's saying is like, um, let's do that. I need like an easier example. This is the linked list case. Like, let's say you're doing 2, right? Len of max heights is equal to 1. Oh no, this is the case where it's furthest down. If you were doing 3, no? Yes. In the case of 3, the height on this level, there's only one node, right? So there's only one height, which is 1. So in that case, you just want to go up, you just want to go up. So it'd be this. Yes, this case makes sense. This case makes sense to me. Thank the Lord it makes sense. Okay, Elif, let's look at the next case. Heights at spot node.val equals max height. Yeah, that means you want to do the next one. Unless, yes. Okay, I understand. Okay. That means you want to do the next max height. But you're guaranteeing it right here, max heights. If len of max heights is greater than 1, you're guaranteeing it's greater than 1. Oops. I don't think you need this. Why would you need this? Does that mean you're assuming it'd be 0? That doesn't make sense. Yeah, you don't need that statement. I don't think. If you do, bro, I'm lost. Right, and then this is just max underscore height without subtree node underscore val is equal to depth plus max underscore heights at spot 0, right? And we're just going to do some magic, some black magic here. I'm not doing it that way, though. How do you spell queries? I'm just copying it. int object does not support. Let me just put this in here just to make sure that this was not the problem. It wasn't the problem. Okay, what? Int object does not support item assignment. Where is the int object? This is an int, but it's not. Huh? What int object? Oh. Right here. Wait. Oh, that's why. Okay, that's an unreal problem, guys. That took me an hour, 24 minutes, and I still don't completely get it. I mean, I get it. He's calculating, like, for each node, he's calculating the depth of the node, which would be 1 in 3's case, the max length of the left and right subtrees. So this would be 1, this would be 2. And he's also calculating the max height of, or is it the depth or the level? The height or the depth? Starting from the thing. Oh my god, this is so goddamn confusing. Oh no, this is the depth. This is not. So yeah, so like the depth, so this would be the depth of 2, and then all the depths of the other trees, right? So it's like this is like 2, this is, or the height of. Oh my god, dude, it like almost made sense in my head. Almost. Okay, bro, let's look at the discussion. I can understand that. Damn, bro, how many problems solved? Holy. So, okay, this guy is a top 8% Leetcode contest, And he just solved his first problem in months. MongoDB software engineer. Sweet intern. What the fuck? This is not a human, bro. Prev, MongoDB seeking. Dude, MongoDB C++ intern is so sick. Software engineer intern backend. Software engineer intern. Bro, I just found the final boss. This guy has interned at Jane Street, Zillow, Amazon, MongoDB. UConn, University of Connecticut. Graduate May 2026. Dean's List. President of the Computer Science Club. Technical lead of Google. He's a TA? Oh, he's a grad student. What? But he's not a grad student. He graduated high school and now he's here. National Math Honors, Math Honor, Competitive Math Club, National Spanish, National Honor, bro, National fucking. This guy's the president of the United States, is what I'm reading right now. This is my competition. This is why my ass can't get a job. We just have Dr. Deadly right here working his ass. Mongo, bro, who are these people? Quantitative developer intern. Bro, if you ever want to feel fucking behind and compare yourself to people that are way smarter than you, man, now I just feel sad. MongoDB. That's actually such a swag job. I'm not even gonna lie. That's so swag. I'm excited to share that I'm interning at MongoDB this summer in New York. Huge thanks to my recruiter for all the support. Bro, this guy has like clout, bro. Marion Wang. Congrats, you're killing it. Bay Area. Hey network, I want to connect. Just a casual Amazon. Twitter, sweet bro. Who are these people? She's Chinese. That's cool for her. She's Chinese, bro. I feel so unbelievably for the people watching this right now and just like seemingly kind of like take a break. I am like I got a couple comments saying like, "Oh, what are you trying to interview at Google?" No, I'm trying to get a job. These are the people who are interviewing at Google. Marion Wang, she/her, she is murdering it. Bro, who are these people? Who is this person? This guy's the final boss. MongoDB, Amazon, Zillow, Jane Street. fucking Jane Street, bro. I can't get over this Jane Street. He's not even a SWE, though. First year trading and technology program. Why didn't you return, bro? This guy is the same age as me, by the way. I have 0 internships. Just want to let you know. This guy is the same age as me. C, systems programming, complexity, and algorithms. UPenn, huh? University of Connecticut. Acceptance rate 55. I mean, this is like a regular school. This isn't like some insane, like I go to Madison. It's like the same, like. They suck. They don't suck, but like. Between 60 and 120, depending on the ranking system used. He probably just like lives in Connecticut, you know? He just chilled there. He probably has like a full ride here too. Like, I mean, it's like he just went there because like he just, you know, guy's a beast, bro. I'm actually glazing really hard right now, but I'm sad now. I shouldn't have done this. I shouldn't have looked in the comments. Bro, and this is the guy, going back to the main point, this is the guy who just barely barely did this problem. Oh, here's the hint. The answers can be pre-computed. Nah, bro. Nah, bro. Nah, these people are just geniuses, bro. 600 problem solved. Contest rating of 8%. What's his website, bro? Wait, is he Spanish or is he corny? I thought he was Indian. Savar? With a name like Savar, bro? Alright, this is annoying as shit, but... Oops. Man, I can't believe he was a Jane Street intern. Bro, Jane Street is like... Bro, fuck Jane Street. I'm actively seeking new opportunities. I specialize in C++ and distributed systems. Do you now? MongoDB. I actually can't get over that. MongoDB, bro. All right. I'm gonna do one more Leetcode. You guys hear the sadness in my voice? Dude, I know this. If someone watching this, some shit like, don't compare yourself. Don't compare yourself, bro. Like, it's not like something you control. Okay, this guy's corny. Word break. It's not like you control, you know, whether you sorry, going back. It's not like you can control how you compare. Like, you compare yourself to others, it's like the same as breathing. You know what I mean? Like, you look at someone who's better than you at the same age and you're like, fuck. Bro, MongoDB, Jane Street, Amazon, like, holy fuck. The Jane Street intern, bro. The Jane Street. I don't even. It wasn't even sweet, but Jane Street, bro. Or I wasn't like quant, I guess. Jane Street. Dude, like I'm not gonna lie. Usually when I compare myself, it's not too bad, but that really just killed me, bro. He's the same age as me. That's just. How are they doing that? I don't understand. Like, I mean, that guy was grinding since like high school, though, maybe even middle school. So it's like it makes sense. Like I mean, he's smart for sure, but he's like probably not some hyper genius. Like, he's just been working at it for like the past like 8 years. Like that's the problem. I don't got that. I've been working for the past fucking 6 months. That's funny. That's not that funny. I'm actually so like, wow. Okay. Okay. Pineapple apple pen. You know what I'm saying? How is this a DP problem? Like, why don't I just like go through this like once I show this like bang, I get here, bang. Oh, because it's multiple. Like one of the dictionary word can be apple pen, and that's why. Yeah. Okay, that's a problem. Okay. My motivation is shot though. I'm not even joking. It has been absolutely teared to shreds after what I just witnessed. Okay. Apple pen, apple, verdict equals apple. Bro, MongoDB Jane. Okay, sorry guys. I'm done. I'm actually done. I'm actually locked in on this problem. So here's the problem that I'm having right now. So this is simple, right? I mean, apple, pen, apple, right? But the issue is, let's say that you had a dict a word dict of a right? And then you had a input of like this, right? Like I would check here, and like this can be like infinite. This can be like 4 A's, 5 A's, like, you know, however many A's, starting from 1 though. And like you check this, yep, it's in there. And then you check this, like you're forced to check this and this, I think. Because let's say instead of pen, it was Apple Pen. Like here, let's just take this for example. Like you would check this, right? Like you can't just disqualify everything and like start from scratch, like with pen, the way you would kind of do it here, or like the way it's obvious. You would have to keep track of this entire word. And do you have to use every single one? of one or more dictionary words. Cat. Yeah, so it needs to use all of them. And how do you use all of them? I don't know. I don't know, guys. In fact, I have no idea. Apple Pen, word dict. Because what I'm thinking right now is I just have like this array, right? Where I have like the word. Bro, my brain just isn't working after that hard problem. Like I have Apple, and then like I also have like I continue like I have a I like build the strings, right? So I have like Apple, and then like I have Apple again. But like I continue to build this one. So like it's like P, no, that doesn't match. No, that doesn't match. No, that doesn't match. Oh, but then I have to build this one too. How the hell do you do this problem? Me when I've been doing Leetcode for like 2 hours and I've solved like less than one problem. You can't backtrack. It's too long to backtrack. Obviously, I know it's DP. I know it's DP. Like, chill. It's probably an O like N times M solution or something, but I don't. Dude, I need a freaking hint. Apple Pen Apple. Dude, I have no idea how to do this. Note that the same word in the dictionary may be reused multiple times in the segmentation. Oh, is that the case? I don't even know where to start. Like I don't know how I would do this problem with that edge case. Like there's an apple here, and then like what do I do after I get the apple? Like I check if it's in the word dict. Oh, it's in there. Okay, cool. What then? And then I go here, and then I append to this one. And then I also start from scratch. Yeah, that's how I would do it. Okay, here's how I would do it. I'm going to do this after this TLEs. I'm going to watch the Leetcode video. Okay. So we need first of all, I think I need to turn those into a dictionary. Or a set. Is a dict guaranteed not to have duplicates? All strings in word dict are unique. Awesome. Can I do .add word for word in word dict? Print hashy. I'm trying to do some Python magic. Okay. Okay. Nice. Okay, then we're going to need the array. We're going to need an array equals one of these right here. Okay? So for C in S. For C and S, if, oh yeah, okay, for, I guess instead of R, we're going to call it DP, just to pretend we're doing dynamic programming. For build in DP, build plus equals C. I'm going to do this for I in range 0 to the len of DP. DP at spot I. If DP at spot I in hashy DP dot append wait, that doesn't work. Oh, I just do an empty string then. Let's see what that does. I mean, yeah, that's used equals 0. We're gonna make this a dict. Word amount bool used or not bool, and then equals false. If DP is spot I and hash DP dot append blah blah blah. If DP is spot I and hash DP dot append. Some don't seem right about that. I don't know what it is though. DP dot. Yo, my brain is just like lagging super hard. Okay, and then we got hashy at spot DP at spot I. Wait, if hashy at spot equals true, used plus equals 1, hashy equals false. False. Equals false. Hash it's by DP equals true. Return used is equal to the len of word dict. Peep that solution right there. Hashy. Hilarious. Oh my god. Who invited this? All right, and then I TLE, and then I'm going to watch the Leetcode video. How the hell is that true? Wait, what? How did I misunderstand the question? Oh, because it's cat. Because you didn't. You can't. Hold on. Print DP. Hold on, everybody. Hold on to your... So I'm noticing that the last one has to be empty. DP. True. If DP at spot -1. Else false. Is that how you do this? Oh my fucking god. I'm asking the guy. Why is this ternary operator invalid? Return true. Wait. Oh my god, I'm actually tripping, bro. Guys, I'm actually just tripping balls right now. Oh. Okay, now I'm just confused. unindent does not match. Bro, what are you talking about? Huh? Oh, that's what you're talking about. Okay, give me the TLE. Just give it to me, bro. I don't even care, bro. I'm a savage. Yeah, bro, just judge it. Judge it, bro. Memory limit exceeded. Unreal. I knew it. I called it. I literally called it with this exact problem. With the A's, bro. God damn. Maybe instead of this, I do a set. No, that doesn't work because it's unordered. Okay. Leetcode save me. Leetcode save me.
Hey everyone.
Hey everyone. It's super loud.
Hey everyone.
That's good now.
Welcome back, and let's write some more neat code today. So today let's solve the problem word break. So we're given an input string and a dictionary of strings called word dict, and we want to return true if and only if S can be broken up into separate strings such that every separate string in S is also found inside of our word dict. And we are allowed to use words from the word dict multiple times. So for example, let's say we're given an input string Leetcode, and we're given a word dictionary of words called leet and code. So obviously, in this case, we could split this string, right, into separate strings, leet, right, break it down in this middle position, and then the second string would be code, right? So clearly, this can be broken up into words that are found in the word dictionary, so therefore we are going to return true.
Man, I really
now, what
memory limit exceed, bro. Unreal.
if we took code outside of our word dictionary? Well, then in that
Well, let me just get rid of. Dude, why does it keep doing that? And the last one is B, bro. That's so toxic.
case, this portion, leet, is a word, right? But we have no matching word in our dictionary for the remainder code. So in that case, we would have to return false. And, you know, let's say we had an
Can I do like if DP at spot I not in? Can I do that? Does that still work? Oh, but then it's just wrong. But now I get memory limit exceeded again. Maybe I even TLE. Time limit exceeded. I'm close, bro.
Input string instead called leet and leet again, right? So 2 leets in a row. Would we return true? Yes, because we're allowed to use this word from our word dictionary multiple times, right? Clearly it matches this, and it also matches the first portion. Now let's start off with the brute force approach. How would we even structure a brute force solution? Well, there's actually 2 ways to do it, but one of them happens to be more efficient, and I'll tell you why. So one thing we could try for an input string like this one, we could check, okay, the first character, right? Basically the first prefix of this string, L by itself, right? Is this a word that's found in our word dictionary? It's not, right? So let's try maybe the first 2 characters together are a word, right? That's not it either. We would try the first 3, right? Basically, we would try every single portion from the beginning until we found a matching word that does exist in our word dictionary. And we know that we are going to find one like this, right? The first 4 characters of the string are a word, right? So once we found that, what are we going to do? Clearly, we have a sub problem, right? We found a matching word for this portion, but now we want to know, can we break up the rest of this string with words from our dictionary? So that's kind of how we're going to do it, right? That's what's going to be the sub problem, basically. So instead of starting from the first position in the string, we would start at this position in the string and try to word break it. Now, in this approach, what we're going to basically be doing potentially is from every single starting position, right? We're going to check every prefix, right? So from the first starting position, we might also get, if this happened to be a word, then we would start at this position and then do the same thing for this, right? Every word starting here. So basically, we're going to try every word. How many different words are we going to end up trying? We're going to try, let's say n is the size of our string n, and we're going to try basically from every single starting position to the end. So that's going to basically be n times n. Now, we could also do it a different way. Instead of trying every single possible, prefix, let's just check every word in our word dictionary and see if that matches. For example, this first word is 4 characters long, right? So what we're going to do is we're going to check the first 4 characters in our string. Does this match this word? Clearly it does, right? So what does that tell us? That tells us now, we have the same sub problem as before. We're going to start from this next position now, right? And check. And from here, we're basically going to be doing the same thing, right? So we're going to check, is leet basically, the first 4 characters, does that match leet? This does not match leet, right? So now let's check the next word in our word dictionary and check, does that match the characters over here? It does, right? We found code. So this is basically another way to do this problem. Instead of checking every single possible prefix, right, of any length, what we're going to be doing is we're going to be checking every single word in our word dictionary as the prefix. So instead of being O of n times n, we're going to be doing O of n because potentially we are going to be going through every single starting position, but we're going to be multiplying by the number of words in our word dictionary, which is, let's call it m. And the reason why we're going to be doing this approach is because it's going to be a little bit more efficient. And the reason is they tell us below in the problem statement that the max size of word dictionary is going to be smaller than the max size of the string. So this is overall probably going to be more efficient. Now, this isn't going to be the overall time complexity. We are actually going to multiply it by another n, because when we're checking, for example, this string, when we're checking, does that match the first 4 characters here? That's also a n time operation, because it could, potentially be the size of the input string s. So this is basically going to be the overall time complexity, n squared multiplied by m. So I'm just going to basically show you the same formula that I usually do. I'm going to give you a quick illustration of what the decision tree would look like. Then we're going to understand how we could cache that to eliminate repeated work. And then by understanding that, we're going to go to the optimal dynamic programming solution, the bottom-up approach, and then we're going to code that up. Usually the DP solution is a lot less code than caching. So we're going to be looking at our input string Leetcode. So I think that's a little bit better than Leetcode, wouldn't you say? So what the decision tree is going to be is we're going to start at the first position, right? For example, I equals 0. We're going to be keeping track of whatever index we're at, right? Because we know that if we can find a word, that matches neat, for example, then the subproblem is going to be, finding words that can match the remainder of the string. For example, if we did that, our I, instead of starting at index 0, would basically be starting at index 4, right? So that's what the sub problem is going to be. So really, we're only going to have one variable that we're keeping track of in this. backtracking solution.
Did I troll? I think I might have trolled. Wait, hold on. Hold the phone. Hold the phone. Wait, let me just quickly... 47. Let me just quickly run through this one more time. Let me just make sure, guys. Let me just make sure. That can't be it. That's an easy problem. Wait, how is mine returning false though? Oh. That's so toxic, bro. That's so unbelievably toxic. And then we go, yeah, okay, it doesn't work. What?
Solution. And so remember, we mentioned we're not going to be doing it like this. We're not going to check every single prefix. We're going to have decisions in our decision tree based on the number of words that are in the word dictionary. So we're going to have a decision for neat, we're going to have a decision for leet, and we're going to have a decision for code. Now, what we're going to notice is when we try leet on here, right, basically leet is 4 characters. Therefore, we're going to check the first 4 characters of here, compare it. Does that match leet? It does not, right? We're just 1 character off, that first one. So basically, that means we're not going to continue down this path. Now, let's try code. Does code match the first 4 characters? Definitely not. So we're not even going to continue down this path either. Of course, neat does match this, so we are going to continue down here. We're going to do 3 more decisions, basically 1 for every single word in our word dictionary. Now, one thing though is when we are starting here, we know we matched the first 4 characters, so by this point we are now going to be at I equals 4, meaning we're going to be looking at this part of the string. So as we can see, checking neat, that's 4 characters long, so let's check 4 characters starting from here. That's not matching, of course, so then we're not going to continue here. Leet, does that match over here? Nope, we're not going to continue down this path. Code, does code match this portion? Yes, it exactly matches. So therefore, we are going to update our I pointer again. Since we matched 4 more characters, we're just going to take I and add 4 to it now. So now I is going to be at 8, and 8 happens to be that exact position right after the end of the string, right? This is where index 8 is. Therefore, we basically know that we were able to match the entire string. Therefore, we know we can return true, right? Once we find a single true, that means we just terminate, we end the function, we can just return true, and the function is done. Now, from this example, it might not be super intuitive why we would use a cache, but let's say we had another path in our decision tree that led us to, for example, index I equals 5, right? And let's say we used all 3 decisions in that path, And let's say none of them yielded the correct result, meaning we were not able to word break this string from starting at index 5. So then we would return false from this path, right? And we would want to cache that. We would want to say that, let's say dp of index 5, right? We would want to set that to false. Basically, what we're saying is if we ever reached this same function call, if we ever tried it again, maybe, this decision tree could be really big. Maybe there would be another path from, somewhere over here where we tried index I equals 5 again. In that case, we would want to return false immediately because we saw from here there was no possible way to break it down. Therefore, we don't need to redo all of that work if we, try the same exact thing. So we discovered that our base case is going to be dp of 8 because 8 is the length of the string, basically, is going to be true, right? If we can ever get to that last index, we're going to return true. So what we're going to do is now do the bottom-up approach, right? We're going to go through every single index in reverse order, right? So we would start at the last character, which is position 7, right? And see, can we word break the remainder of this string? And we would try every single word, right? Like neat, does neat match this string? Well, they're not even the same size, right? If we tried to match neat on 4 characters starting from here, we would go out of bounds of this string, right? There's not enough characters. So of course, this is going to be false, right? It wouldn't match neat. It wouldn't match the other 2 words in our dictionary either. And that's obviously going to be true for dp of 6, dp of 5, as well. So both of these are also going to be false, right? Basically, if we started from 6 or if we started from 5, we would not be able to match any of the words in our dictionary. But now if we start here, index 4, so we're now trying to figure out dp of 4, is that true? Well, yes, it is, right? It doesn't match neat, it doesn't match leet, but it does match code. So we are going to set dp of 4 equal to true. So now let's keep doing it until we get to the first character. So now we're going to be trying from dp of 3, right? So starting from this character, are we going to be able to match any of these? Well, none of these words even start with a T, so of course we're not going to be able to match. So dp of 3 is going to be false. What's dp of 2 going to be? It's also going to be false because if we were to start at this character, this E, would we be able to match any of the words in our word dictionary? Of course we would not. And what about this position? If we started here, would we be able to match any of the words in our word dictionary? Again, not. So dp of 3, dp of 2, and dp of 1 are going to be false, meaning we cannot word break this string if we start at any of these 3 positions, basically. Now we're finally at the result that we were looking for, dp of 0. Is dp of 0 going to be true? Well, let's take a look. So we're starting at the first character in the string. Can we match any of the strings? We can't match leet, we can't match code, but neat, it does match this portion of the string starting at index 0. So then the question becomes, we're asking, can we break the entire string starting at index 0? So now, since we did match the first 4 characters, we want to know, were we able to match the remainder of the string, right? So we want to know, starting from here, were we able to match this string to words in our word dictionary? Now, this is why we computed this bottom up, right? Because this is index 4, right? Notice how we already computed index 4 over here, right? It's the one that's highlighted in green because it was true. We were able to do it. So basically the equation that we would use for this is going to be dp of 0 plus the length of the word that we were able to match with, and we know the length of the word neat is going to be 4, so basically we can replace this length of the word with 4, so 0 plus 4 is just dp of 4. We know that was true, so we can set dp of 0 equal to true. So this is basically the result, right? This is how we're going to compute it, and this is what we're going to assign.
What the sigma? Yeah, I don't know about all that. Okay. All right. Okay, so dp How do you make a initialize array size? Okay. Len of s. One, 2, 3, 4, 5, 6, 7, 8, 9. Nice. Okay. So for I in range, len of s minus 1, minus 1, minus 1. Let's just do word equals s at spot I to the end. And then it's I plus. Okay. For word in word dict. If I plus len of word. So let's just say, let's go back to this one. Code. So I is 0, 1, 2, 3, 4. 4. 1, 2, 3, 4, 5, 6, 7, 6, 7, 8, 9. So 8 minus 1. Is less than or equal to len of s. Something happens. DP at spot. Okay, so wait, if s at spot I to len of word is equal to word, at spot I is equal to dp at spot I plus len of word. All right, where's the, this seems terribly wrong. True. Oh. Print word. Leet. It should print code though. Oh, plus I. There you go. It's that. It's I plus. There we go. Return dp spot -1. Are you? Oh, not -1. It's 0. Oopsie daisy. Why did I submit? Oh, shit. Yeah, I'm gonna say. What's going on, dude? What's going on? This should be true. But it's here, though. I don't understand. Zero, 1, 2, 3, 4. That's accurate? Zero, 1, 2, 3, 4. 3. So I don't get it. It's 0, 1, 0, 1, 2, 3. 3 plus 4 equals 7. 0, 1, 2, 3, 4, 5, 6, 7. It should just be true, though. But it's not. Zero, 1, 2, 3, 4, 5, 6, 7. 3, 7. So 0, 1, 2, 3 is equal to 0 1, 2, 3, 4, 5, 6, 7. What the huh? Something's a little fishy. 0, 1, 2, 3. There it is. It gets overwritten. Oh, it gets overwritten. Ah, break. Is it still wrong? Oh, shoot. This is true. ARS. CARS. I'm gonna lose my mind, bro. 2 hours and 30 minutes for 2 Leetcodes. I think I'm doing this wrong. 0, 1. Oh, wait, I'm stupid. If DP at spot I is equal to true, break. There you go. All right, now it's done. Now I have solved it. Yes. Dude, it's been 2 hours and 30 minutes, bro. What? Like, you just can't have nice things, bro. You just can't. You just can't, dude. Let's look at his solution though. Before I start the project.
And
for
DP of
like
0,
40
2.
minutes.
And once we've done that, we've computed the result. We know we can return true for the overall function. So with that being said, let's jump into the code. So our cache is going to be, let's say, a one-dimensional array, right? Because for every position I in the string S, we are going to have a value. So we're going to initialize this to false. It's going to be the length of the string S plus 1 for our base case. And we are going to initialize our base case. We know that it's the last position, basically the position out of bounds of the string.
Dumb.
So the length of S, and we know that's going to be set to true. That's our base case. So now we're going to go through every position I in the length of the string, starting at the last index and working our way to the beginning. So that's why I'm using the decrementer of -1, and we're going to go up until the beginning of the string. And for each position I, we want to try every single word in our word dictionary and see if the word matches this portion. So first, we have to see if starting at position I, the string S even has enough characters for W to be compared to it. So what we're going to do is we're going to check I plus the length of W, and we want to know, is it less than or equal to the length of S? If that's the case, then that means there are enough characters in S for us to compare them. So that's exactly what we're going to do. We're going if this is true, then let's compare. So we want to know if that's true and if S starting at index I, going up until I plus the length of W. So basically, let's say W was 3 characters, then we want to know the first 3 characters in S starting at index I, are they exactly equal? If they are equal, then we want to know, okay, so DP of I is going to be set to DP of I plus the length of W, right? That was the relationship we got, I plus the length of whatever the word happens to be. Now, if we got a single way to word break this starting at index I, that means we can basically stop this loop, right? We don't have to look at every single word in the dictionary. If we found at least one way we were able to word break it, then we're going to stop. So basically, if DP of I is true, then we can break out of this for loop and then move on to the next index. So we're going to start basically at the last index, keep going until we've gotten to index 0, and then once we've done that, we know we can actually return that, and that's going to be stored in DP of 0. So believe it or not, that is the entire code.
Wait. Do you not need this -1? Ah, shoot. Word break 2, hard. Okay. Yeah. I'm gonna work on the project for 30 minutes, and that's gonna be that. Man, 2 hours for Leetcode. I'm not happy about that. For 2 problems. What are you gonna do though? Man, oh man, oh man. All right, let's open up this one. So for 30 minutes. 30 minutes, 30 minutes, 30 minutes. Man. Okay. What the Oh, is this like a get blame? That's cool. All right, what do we got so far? All right. So one thing I need to add is I need to load all of the stuff in a file. Yeah, I don't know how to do that. How to load your mom. Huh, am I right? Okay. Sorry, that was stupid. How to load. How to read. Oh, how to read a directory. Directory in Java. All right. So let's do private. Or public. Static. Public. Can I do final static? Songs directory. And this is what is this, string? Oh, equals. I said it's not Sunday. We just hit the. Okay. Public. Let's do void. List files for folder. Also, this is. List. I guess it's final file folder. For final. Whoops. File folder. Final file entry. Folder.list files. Huh. Don't you love Java? Hmm. Hey, why can't I do it? Oh, it takes a file. Dude, what? Why can't I do it in here? Why me? How do I want to do this? What's the best way to do this? I just need to create the playlist, the main playlist of all the songs in the songs directory. Can I get absolute file? Okay. Whoops. Wait, what is get name print? Sorry, I'm just super like tripping right now. Okay, that's fine. All right. Okay, and I'm gonna do a playlist in here. Playlist. And then I'm gonna delete this. And then it's gonna be playlist.add song. Song's terrible. You guys should be happy you guys can't hear it. I think I'm going to repeat this every time, but copyright is the reason I can't have the songs playing, guys. All right, I got copyrighted. Not cool. I don't really know what happens when you get copyrighted. So I'm just like, nah, I got to worry about it. I think it's like you can't make money. I don't make money anyway from these videos. There's no ads. But I don't like when it says copyright. Okay, it makes me nervous. And you guys aren't missing out, bro. Okay. Now I need a way to make playlists. Which I don't think I can code up in 20 minutes, but maybe I can. I need a list of playlists. Which is probably a new class. Playlist. Private. What is array list? Okay. A playlist. Playlist. Playlist list, bro. Let's do catalog, bro. Does each playlist have a get name? String playlist name. Get size. No. I'm trying to remember like. But how do I like. How do you make the thing automatically? Boom, boom, boom. So in this playlist catalog, I need to display it. Wait, what? Playlist E. Playlist. Why? Why would it be null? Oh. Wait. Tell me that's not how Java works, bro. That is so ugly. the hell? Okay. And now I need to make. I need to display all the playlists. How do I do that? Private VBox layout. Probably like that. Private VBox layout. Get VBox. If layout doesn't equal null, no, I don't need to do that. Can I just add it? Like public get VBox. Okay, why did it work there? Whatever. Hello? I'm with that. Okay. For playlist. Right. Layout dot get children dot add playlist dot get VBox. Return layout. So I need a add playlist and delete playlist method. How do I do that? I need to add and delete. Okay, well, public void add to playlist catalog. Well, I think this might be like overdoing it. Okay, but then I need to refresh the layout. That's the secret. So which means return value is never used. Shut up. Okay, so if layout doesn't equal null. Layout dot get children dot clear, right? What? Isn't that how this does it? What? Wait, why is this wrong? What? Public void delete. Delete playlist in catalog. The reason I'm doing one is because I don't want you to ever to be able to delete the main playlist, which is just every song in the thing, in the file. I is less than something. I don't know what it's less than. I is less than dot size. If at spot I, shoot. If playlist catalog at spot I. Array type expected found. Sure. Man, you can't do bracket indexing in Java. It's a method to get the index, or have we lost our minds? I feel like I knew that, but I just really don't like that. It's so ugly. If dot remove I. Suspicious. Break. It's suspicious, bro. Suspicious. It's calling my code sus, bro. That's crazy. Okay, let's try. We gonna. Okay. Main controls. I'm not gonna lie, guys. I don't think this is gonna work the way I. Oh, it did. Okay. In my spaceship. All right. Wait, am I stupid? So this should give me two of the same one. Nice, bro. Okay. Now the issue becomes like these stupid ass buttons. Oh, yeah. That's not good. How do I even want to handle that, dude? Is there like a stop function to like stop the entire thing? Play song, play next, play all. Oh boy. That's not helpful. In fact, that's actually not helpful at all. Okay. That's a problem for another day. Let's do an easy, medium to or easy. Nah, is that even worth my time? Probably not. All right. Peace out, y'all. I'm done. Wait, I need to commit. Oh my god, I almost forgot. Not suicide. Like git commit dash read from songs dir playlist catalog class. All right.